Good evening, everybody. Here you can see the picture of John Napier. Why John Napier only? Because today we are going to discuss logarithm, and logarithms were invented in 17th century by this Scottish mathematician John Napier. Actually, he coined the term from Greek words, logos, which means ratio, and arithmos, which means number. Yes, you have to remember this, that language of physics is not English, it is mathematics. So even if you are thinking of doing or concentrating on PCB, you should know basics of mathematics. As I said, I'm going to cover logarithm because you are supposed to use log tables not only in physics but in chemistry also. Of course, in board exam, use of logarithmic tables is not allowed in CET or JEE Main or NEET exam. Then you'll ask me, then why to study log tables or logarithm? See, the word logarithm is used many times in physics. There are some mathematical expressions, rather formulae, in which logarithm is used, even in chemistry also. That is why you should know logarithm. Now, after logarithm, I'm going to take angles. You have this topic in mathematics in 11th standard, angles and its measures, because in 11th standard, we are going to see angle through different angle, altogether different definition of an angle. And then of course trigonometry, formulae for sine of 2 theta, then sine A plus sine B and so on, because you need this formulae, especially formula for sine 2 theta in physics. And at the end, we will be discussing most interesting topic, that is calculus. In calculus, we will be discussing limits, derivatives and integration. Now, if you have any difficulty, you can ask that difficulty, but please ask the difficulty after the session is over. In between, I'll see your messages like please repeat this, go slow, like that. But otherwise, if you have any queries related to other topics, I will be there at least for 15 minutes after the lecture. Okay. So I have said this before, that this is not a spectator sport, mathematics is. So you have to participate in that. So let us play. Now, logarithm. Of course, for logarithm, you should know laws of indices. I will not explain all the laws in detail, but I'll just mention them, that a raised to m into a raised to n is a raised to m plus n. A raised to m upon a raised to n is a raised to m minus n. A raised to minus n is 1 upon a raised to m. Then a into b raised to m is a raised to m into b raised to m. A upon b raised to m is a raised to m upon b raised to m. This is important. A raised to m raised to n is a raised to mn. Now mn is m into n. Similarly, n into m also. So I can write this as a raised to n raised to m. Now a raised to 0 is 1 provided a is not equal to 0. This is important. A raised to 0 is 1 provided a not equal to 0. Okay. Now, let a raised to x equal to m. We are going to call this as an exponential function. There are different types of functions like linear function. You must have heard about linear function. Why linear? Because its graph is a line, straight line. Similarly, this is an exponential function. What are the restriction on base? Base is greater than 0 and not equal to 1. I repeat, let a raised to x be m. Here a is called as base, x is called as an index or exponent or power, and m is the result. What are the restrictions on base? Base has to be greater than 0 and not equal to 1. These are the required conditions. If this is so, then index x is defined as logarithm of m to the base a. How to read this? Logarithm. Log is the standard short form of logarithm. So logarithm of m, you have to write log and m in one line, and this is the base, right? So logarithm of m to the base a. Note that these two are equivalent forms. This is an index form. This is a logarithmic form. Given one form, you can convert it into another form. I will give you examples. What is 4 cube? 4 cube is 64. Therefore, index 3 is defined as logarithm of 64 to the base 4. So can you define logarithm in different manner? See, logarithm is the power to which base should be raised. 4 raised to which number is 64? 4 cube is 64. And that is why log 64 to the base 4 is 3. You may say 4 plus 60 is 64. So is log value 60? No. You may say 4 into 16 is 64. So is log value 16? No. Logarithm is the power to which base should be raised. 4 raised to which number is 64? 4 cube is 64. Right? Now, another example. What is 7 raised to minus 1? I hope you won't say minus 7. 7 raised to minus 1 is 1 upon 7. Raised to minus 1 means reciprocal. Therefore, I can say index minus 1 is logarithm of 1 upon 7 to the base 7. What is 10 raised to 0? 10 raised to 0 is this correct? No. I'm going to write 1, O-N-E. So 10 raised to 0 is 1. Index 0 is defined as logarithm of 1 to the base 10. Just check this. What is logarithm? Logarithm is the power to which base should be raised. 10 raised to which number is 1? 10 raised to 0 is 1. That is why 0. Now listen to me carefully. I'm going to make one very, very important statement. The statement is logarithm of only positive number is defined. Can you justify this? See, when I say a raised to x is m, a has to be greater than 0, not equal to 1. So if base is positive and not equal to 1, m is always positive, and our aim is to find logarithm of m only. And therefore, the conclusion is logarithm of only positive number is defined. Log 0 not defined. Log of negative number not defined. See all these examples. Base positive, 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 not 1. Index is positive, index is negative, index is 0. But we have obtained logarithm of only positive number. One student is saying, but sir, minus 3 cube is minus 27. Yes, absolutely right. So can we write index 3 is defined as log of minus 27 to the base minus 3? No, this is correct. Minus 3 cube is minus 27. But remember, logarithm is defined only if base is positive. Is minus 3 positive? No, not only positive, but not equal to 1 also. See, this is the number line. Less than 0 means to the left of 0, negative. To the right of 0, positive. Is that clear? And therefore, logarithm of only positive number is defined. Some students are asking, can the base be complex? No. When I say a greater than 0, See, if you know complex number, that is why I have already told you that please ask questions. Actually, these are not relevant questions, but still I will answer them, but after the lecture. When I say greater than, see, in complex number, if two complex numbers are there, there is no inequality between them, that one is greater, other is smaller. So please do not ask questions, such questions rather right now, because you don't use complex numbers in physics, and you haven't done complex numbers in mathematics yet. Okay. Now another student, this is also, I won't say this is an irrelevant question, but he is asking me, what is minus 4 square? It is 16. So can we say that 2 is log 16 to the minus 4? I would not have asked this question. I would not have asked this question because I'm told that base is not allowed to be negative. Base should be greater than 0. Is minus 4 greater than 0? No. So this is not allowed. Say loud, it is not allowed. Okay. Now, another statement. I have already made one statement. Logarithm of only positive number is defined. Another statement is log value can be any real number. You must have heard about real number. We begin with natural number 1, 2, 3, 4, etc. Then comes whole number, set of whole numbers, because 0 is included in that. Then set of integers, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Then set of rational numbers, p upon q. Q not equal to 0, p, q are integers. Example, 1 by 7 is a rational number. Then irrational number, root 11 is an irrational number. Now the superset of all these sets is the set capital R of real numbers. My statement is log value can be any real number, and this is quite logical. Why? Because index is nothing but the log value. So can index be negative? Yes. Can index be 0? Yes. Can index be positive? Yes. And that is why we say that log value can be any real number. See, 3, minus 1, 0 are the log values, but logarithm of only positive number is defined. Is that clear? Now tell me, what is log of 64 to the base 32? Okay. We are asked to find value of log 64 to the base 32. Okay. We begin with, let the value be x. Now logarithm is the power to which base should be raised. Write this in index form. So 32 raised to x is 64. Now we are interested in finding x. So we must write this equation with the same base so that indices can be equated, right? So 2 raised to 5 raised to x, 64 is 2 raised to 6, a raised to m raised to n. So 2 raised to mn, so 2 raised to 5x, 2 raised to 6. So 5x equal to 6 because base is the same. So x is what? 6 by 5. But we have taken x for log 64 to the base 32. So my answer is log 64 to the base 32 is 6 upon 5. Okay. You can try this after the lecture. Log of say 27 to the base 1 upon 81. Please do not solve this right now because we are going to discuss the next part. Then log of root 5 to the base root 5, and logarithm of which number? 625. Okay. Now base of logarithm plays an important role. Means what? See, what is 4 square? 16, right? What is 2 raised to 4? 16. What is 16 raised to 1? 16. What is square root of 256? By square root we mean positive square root. 16. Now index 2 is defined as logarithm of 16 to the base 4. Index 4 is defined as logarithm of 16 to the base 2. Index 1 is defined as logarithm of 16 to the base 16. Index half is defined as logarithm of 16 to the base 256. Note that every time we find every time we find logarithm of 16 only, but as the base varies, log value also varies. So base of logarithm plays an important role. Base can be any number greater than 0 but not equal to 1, but mainly two bases are used. One student is asking, are we supposed to write this? It depends on you, man. Come on, if you can give justice to both, that if you can listen to me and at the same time write, then I have no problem. But I have already uploaded this file on the website. The first base is 10. It is called as common logarithm. It is called as common logarithm, and it is used in log tables. In log tables, all the values are obtained considering base of logarithm as 10. So it is used in what? Log table, logarithmic table. Okay. Now the second is also an important one, second base. It is E. What is E? E is an irrational number. And when E is used as base of logarithm, it is called as natural logarithm. Natural logarithm is used in calculus, that is in limits, derivatives and integration. Let me explain. Then I'll ask, rather solve your queries. I'm again telling you that what is E? E is an irrational number. So what is the value of that? Of course, it doesn't have exact value, but 2 less than E less than 3. E is greater than 2, but less than 3. Now, do not ask me why, how, because our aim is not to study mathematics in detail. We are interested in discussing that part of mathematics which is useful in physics. Otherwise, it will take more than a year, and we have to complete this course in just 6, 7 or 8 lectures. Okay. So 2 less than E less than 3. And what is the approximate value? 2.7182818. Is it necessary that you remember this? No. Just remember that E lies between 2 and 3. On scientific calculator, you will see two buttons. On the first, LOG will be written, LOG. So LOG means common logarithm. And on the other, ln will be written. So by ln x means natural logarithm. So it is customary not to mention the base of logarithm if it is e. When we are doing calculus, by even if we write log x, by that we mean log x to the base e. Is that clear? I repeat this part. There can be any positive real number not equal to 1 as the base of logarithm, but mainly two bases are considered. Number 1, base of logarithm is 10. It is called as common logarithm. It is used in log tables. Secondly, base of logarithm is e. What is e? E is an irrational number. Its value lies between 2 and 3, and the approximate value is 2.7182818. Now, common logarithm is used in log tables, and natural logarithm, which is also called as Napier logarithm, is used in calculus, that is limits, derivatives and integration. Now, basically, why do we use log tables? See, some students have tendency of answering that log table or logarithm is asked for 3 marks in the exam. That is not the correct answer. You should not think on these lines. Otherwise, a student doing Bachelor of Arts, BA in Marathi will say, I will keep Jnaneshwar for option because weightage for Jnaneshwar is only 3 or 4 marks. That is not uh, the correct attitude. Okay, correct tendency. Now, why do we use log tables? The reason is simple. Using log tables, calculations can be done easily. See, in log tables, we are interested in considering indices. So, multiplication is converted into addition and division is converted into subtraction. This doesn't mean that instead of 15 into 4, we will just say 15 plus 4. No, logarithm of 15 into 4 will be logarithm of 15 plus logarithm of 4, right? Now, for this, we should know rules of logarithm. I will just mention the rules. Proofs are not required. Still, I will explain proof of the first law. If you are interested in proofs of remaining laws, you can refer to a mathematics textbook. So, rules of logarithm. If you want, you can write this because we are going to use these rules. I think I have given all these rules in this PDF file. Yes, I have. See, I have already uploaded this. And you were expected to go through this, go through recorded lecture. See, everything I have mentioned. Yes. Please write down this. Laws of logarithm. I will explain the proof, don't worry. Because if you know the proof, result can be remembered easily. Logarithm of mn is logarithm of m plus logarithm of n. See how product is converted into addition. Please write this also in words. Logarithm of product is not product of logarithm. It is sum of the logarithms, SUM sum. Fast. Please don't take screenshot. If everybody is going to take screenshot, then fine. I'll just scroll it up. Second, logarithm of quotient. Log of m upon n is log m minus log n. See, division is converted into subtraction. This is very important. If I ask you, find the value of 11 raised to 1 by 3, that is cube root of 11. Then log of 11 raised to 1 upon 3 becomes 1 upon 3 log 11. Log 11 can be easily obtained using log tables. I already actually told you about third one, logarithm of power. Log of m raised to n is what? N log n. If I ask you to write this law in words, logarithm of power of a number is that power into logarithm of the number, right? If you want, you may write fourth one, change of base, but as far as physics is concerned, this is hardly used. But write down this, log a to the base a is 1. This is logical. Why? Logarithm is the power to which base should be raised. A raised to which number is a? A raised to 1 is a. So we can draw the conclusion that logarithm of any number to the same base is always 1. Next one, write this also. log 1. Now, don't say that this is baseless logarithm. How can logarithm be baseless? Don't make such baseless statements. See, base is not mentioned. If you want base as 10, what is log 1 to the base 10? 10 raised to which number is 1? 10 raised to 0 is 1. So log value 0. If you say, no sir, I don't like 10. I want base as e. No problem. E raised to which number is 1? E raised to 0 is 1. So the conclusion is logarithm of 1 to any. See, I have written one important word in bracket. Any valid base. Otherwise, you may say, sir, is log 1 to the base minus 3, 0? How can it be? How can base be minus 3? No. So logarithm of 1 to any valid base is always 0. Many students have habit, even some teachers also make this mistake. They read this as log into m plus n. That is absurd. This is not multiplication of log and m plus n. Ideally, you have to read this as logarithm of m plus n, ideally. But we are idle, so we do not read this completely logarithm. We just say log. So log m plus n is not log m plus log n. Because what is log m plus log n? Log m plus log n is log mn and not log of m plus n. So don't take log common. Similarly, in trigonometry, do not read sine into x. That is actually sin. A sine sin. You have to read this as sine of x. Cos into x is wrong. Cos x, that is cosine of x. Now, one question is asked, is square of log a 2 log a? No. Why? Because what is square of log a? It is log a into log a. That is log 2 into log 2. But what is 2 log 2? 2 log 2 is log of 2 square. Third law, log of m raised to n is n log m. So they are not equal. We will discuss this afterwards. Let me ask you one question. Let me ask you one question. What is log 1 to the base 1? See, what is logarithm? Logarithm is the power to which base should be raised. See, 1 raised to 0 is 1. 1 raised to 1 is also 1. So, which of the two values is correct? Type your answer in chat box. Very good. Most of the students have given the correct answer. The question itself is wrong. See, log 1 to the base 1 is not acceptable, because when we say a raised to x equal to m, a base has to be greater than 0, not equal to 1. Is that clear? And that is why log 1 to the base 1 is absurd. It is not defined. Okay. Now we have to discuss calculations using log tables. See, when we use log tables, it is not necessary to mention the base because it is 10, common logarithm. What is 10 raised to minus 1? 0.1. So log of 0.1 is minus 1. What is 10 raised to 0? 1. So it is log 1, it is 0. It should be 0, not 1. I have corrected it now. What is 10 raised to 1? 10. So what is 1? Log 10. That is log 10 is 1. Similarly, what is log 100? 2. What is log 1000? 3. Now listen to me carefully. If I ask you to tell me what is log of 7, can you tell me the exact value? No. But you can tell me that 1 less than 7 less than 10. Do you agree with me? 7 is basically greater than 1 but less than 10. So its log value will be greater than 0 and less than 1. Do you agree with me? See, if I ask you to tell me the approximate value of log 7, what will you do? You will say that 7 is greater than 1 but less than 10. Log 1 is 0, log 10 is 1. So log 7 will be greater than 0 but less than 1. This means log 7 is, see, 0 point something, 0 point something. Okay. If I ask you to find approximate value of log 74, your answer should be 2 point something. Yes or no? Yes. Why? See, base of logarithm is 10. 10 raised to 1 is 10. I'm sorry. I should have written 1 point, not 2 point. See, what is 10 raised to 1? 10. What is 10 square? 100. 74 is less than 100. And therefore log 74 is what? Greater than 1 but less than 2. And that is why I have written 1 point something. Now, what is log of 343 to the base 10? It is definitely 2 point something. Yes or no? Yes. See, 10 square is 100. 343 is greater than 100. 10 cube, 1000. 343 is less than 1000. This means log value of 343 is greater than 2 but less than 3, and that is why I have written 2 point something. See, I have written this just to tell you that log value consists of two parts. This is called integral part. 0, 1, 2, all these are integers. And this something something part is called as fractional part. Have we used log tables to find 0, 1, 2? No. This means integral part can be written by observation. And for this fractional part, this something part, we have to use log tables. So first we discuss how to find this integral part. Before that, let me write that log value consists of two parts. The first is integral part, second is fractional part. Integral part is called as characteristic. It is called as characteristic, which is written by observation. Fractional part is called as mantissa. It is called as mantissa. And to find the mantissa, we have to use log tables only. And for characteristic is written by observation. I repeat this part. Each log value consists of two parts. Integral part, fractional part. Integral part is called as characteristic, which is written by observation. Fractional part, which is called as mantissa, is obtained using log tables. One important thing about fractional part, that is mantissa is always positive, or in some cases 0 also, but otherwise it is positive, that is non-negative. Now characteristic is the index, so it can be positive, negative or 0. Now this part is a bit difficult, so listen to me carefully. See, if the number is less than 1, if the number is less than 1, log value is negative. Many students think less than 1 means negative. No, less than 0 means negative. And logarithm of negative number is not defined. And that is why, let me complete. Some students are asking irrelevant questions again. Have patience. Therefore, we are going to consider two cases. Numbers which are less than 1 at the same time greater than 0. Why? Logarithm of only positive number is defined. But there are infinitely many numbers between 0 and 1. See, this is the number line. We are interested in numbers to the right of 0 because they are positive. At present, we are discussing numbers between 0 and 1. So I will write the number and I will write characteristic. Okay, because characteristic is written by observation. I am not explaining the concept of mantissa. It will take another 5 to 6 minutes. Suppose number is 0.04. Another number 0.0707. Third is 0.007. Fourth one 0.1 to ka 4, 4 to ka 1. Okay. Now don't ask me to take number like minus, absurd. Logarithm of negative number is not defined. We are considering cases of numbers which are less than 1. And for them, this characteristic is negative. Now for the number 0.04, characteristic is -2. For the number 0.0707, characteristic is -2. For the number 0.007, characteristic is -3. For the number 0.124421, characteristic is -1. Now, fractional part is always positive, and therefore negative characteristic is written using bar notation. Instead of writing -2, we write bar 2. Bar 2 means -2. Here bar 2, bar 3, bar 1. The reason I'll explain once again. How will you read this number? -1.4141. Here this part 0.4141 is also negative. But if this is fractional part, that is mantissa part, this cannot be negative. So though characteristic -1 is negative, this part is positive. So instead of writing this, we say it is bar 1 0.4141. This is the correct way to present negative characteristic. See, before this, we haven't seen such numbers that fractional part positive and integral part negative. But in logarithm, in log values, yes, this integral part, that is characteristic, can be negative. Okay, I'll tell you the working rule. See, if the number is less than 1, characteristic is negative, and it is one more than number of zeros immediately placed after decimal point. That is number of zeros between decimal point and first significant digit. Otherwise, what will happen? Here you will say, sir, there are 2 zeros after decimal point. Come on. Then there can be 2000 zeros also, because 0.04 is what? 0.04, 0, 0, 0, 0, 0, 0. These zeros are useless. Zero itself is not useless, but these zeros are useless. So characteristic is one more than total number of zeros immediately placed after decimal point. There is only 1 zero after decimal point. So one more means 2, but negative because number is less than 1. So char is -2, that is bar 2. 0.0707, there is only 1 zero immediately placed after decimal point. So characteristic is -2. I have already explained the reason. 10 raised to -1 is 0.1. 10 raised to -2 is 0.01. 10 raised to -3 is 0.001, and that is why. Okay. So for third, there are 2 zeros immediately placed after decimal point. So characteristic is one more than total number of zeros. So 3, but negative. So -3. Using bar notation, bar 3. There is not a single zero immediately placed after decimal point. So 0, 0, but 1 you have to add to it. 0 plus 1, 1. So char is 1 with negative sign, that is -1, that is bar 1. So working rule is simple. If the number is less than 1, characteristic is negative. It is one more than total number of zeros immediately placed after decimal point. Is that clear? Now, fractional part is always positive. So negative characteristic is written using bar notation. Let us consider numbers which are greater than 1. So number, and I will write characteristic. The first number is 1.21. Second number 21.001. Third number 1760. Fourth number 339.12. One more number 1.001001. Okay, now I will write characteristic. Number is greater than 1. So characteristic is positive. See, characteristic is the index. Use common sense. 10 raised to 0 is 1. 10 raised to 1 is 10. So 1.21. What is the log value of this? It is definitely 0 point something. So characteristic is 0. Here characteristic is 1. Here characteristic is 3. Here it is 3. Here it is 0. I'll write one more number. 9552761. Characteristic is 7. Now can you tell me the working rule? Working rule is simple. If the number is greater than 1, characteristic is always non-negative, because I should not say positive, or if I say positive with an exception, because 0 is neither negative nor positive, right? So for number 1.21, characteristic is 0. Working rule is characteristic is 1 less than total number of digits in the integral part. Integral part is 1. 1 is a 1 digit number. So characteristic is 0. What about 21.001? See, I have seen many students who say characteristic is 20. He say 21 is a 2-digit number. I am not saying number minus 1. I am saying number of digits minus 1. So characteristic is 1. See, I will tell you logic once again. I have asked you what is the approximate value of log 21. 10 raised to 1 is 10. 21 is greater than 10. So log value is more than 1. What is 10 square? 100. 21 is less than 100. So log value will be less than 2. I'm telling you that only 1 point something. So what is characteristic? It is number of digits in the integral part minus 1. Now 1760 is a 4-digit number. Characteristic is 4 minus 1, that is 3. Now 3139.12. Don't say it's a 6-digit number. You have to consider integral part. It is again a 4-digit number. So characteristic is not number minus 1. It is number of digits minus 1. So 4 minus 1, that is 3. Integral part is 1. It's a 1-digit number. Characteristic is 1 minus 1, that is 0. Then this is 3 plus 2, 5 plus 3, 8. 8-digit number. So characteristic is 8 minus 1, that is 7. I hope this is clear to you. So there are two cases. First case, if the number is less than 1, characteristic is negative, and it is one more than total number of zeros immediately placed after decimal point. And characteristic is written using bar notation. So do not say, or do not write rather, that characteristic is minus 7, say it is bar 7. Second case, if the number is greater than 1, characteristic is always positive, and it is 1 less than total number of digits in the integral part. Okay. Now we will see how to find mantissa. So number, char, characteristic and mantissa. See, we are going to use 4-figure log table. Even if you have not downloaded that file, I'll show you the log table. See, this is the log table. Starts with 10. First column headed by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And again 9 columns headed by mean differences. So the first row, horizontal line is row, vertical line is column. First row is headed by 10, okay, and the last will be 99. So this is about log tables. Remember, it is a 4-figure log table, okay. Now consider the number 1, 2, 3, 4. Listen to me carefully. See, you won't be able to write on your own just in 1 or 2 minutes. Let me explain first. Now, the number is 1, 2, 3, 4, greater than 1. So what will be the characteristic? There are 4 digits in the integral part. So characteristic is 1 less than total number of digits. So characteristic is 3. Is that clear? Now, mantissa. See, it's a 4-figure log table. One, two, three, four. So we have to find, let me explain. We have to find the number which is in row 12. First 2 digits give the row number and third digit gives the column number. So can you tell me the number which is in row 12 and column 3? See, row 12 and column 3. See, 0899. Many students drop this 0. That is wrong because these 4 are to be written after decimal point. So how can you drop that? So the number, see the point of intersection of this row and this column, 12th row and third column, 0899. Okay, 0899. So this is the number which is in row 12 and column 3. To it, you had to add the number which is in the same row, that is row number 12 and column 4, but in mean difference section. See, same row 12, but column 4 in which section? Mean difference section. So that number is 14. I hope you will not say that write 14 here. This is absurd. This is adding 1400. Okay, so we have to add 14, 1 4. So tell me what is the total? Okay, so this is mantissa 0913. So can you tell me the final log value? It is 3.0913. See, I could write this directly because integral part is what? Positive. Had it been negative, I would have written bar 3.0913. Is that clear? Now the next number is 17.16. Integral part 17, it is a 2-digit number. Characteristic is 1 less than total number of digits. Okay. Now first 2 digits give the row number. Third digit gives column number. To it, we have to add the number which is in the same row. In this case, 17th row, but column 6 in mean difference section. So tell me 17th row, first column. See, 17th row, first column, 2330. 2, here I will write 2330. Now to this add the number which is in the same row, that is row number 17 and column 6 in which section? Mean difference section. So 17th column, I'm sorry, 17th row and let me see once again. column 6. Okay. 17th row and column 6 in min difference section, which is that 15. So you have to add 15 to this. So I will directly write what is 2330 plus 0015. It is 2345. This is fractional part, remember. So what is the final log value? 1.2345. See, this is quite logical. 10 raised to 1 is 10. This is greater than 10. 10 square is 100. This is less than 100. So it is 1 point something log value. Yes, it is 1.2345. Many students are writing 2345. No, you have to say 0.2345 because that is fractional part. Okay. Now I will write one number. You have to tell me final log value. Okay. 191.5. Yes, type your answer in chat box. Now 191.5, clearly it's a 3-digit number, so characteristic is 2. What about Mantisa? Find a number which is in row 19 and column 1. Row 19 and column 1. So 2810. To it add the number which is in the same row, that is 19th row, and column 5 in mean difference section. It is 11. Still some students are writing 11 here. I hope you understand the difference between 1100 and 11. 11 means 0, 0, 1, 1. Mathematics is all about using common sense, but unfortunately it is uncommon. So 2821, but after decimal point. So it is 2.2821. Now, 1 minute, I'll give you one more, then we'll stop. Suppose it is 13. Tell me. See, number is 13, 2-digit number. So characteristic is 1. Can I write 13 as 13.00? Yes, I can. Now find a number. See, this is very important. Otherwise, you will say, so no Mantisa, because we do not know column number. So find a number which is in row 13 and column 0. That is why first column is headed by 0, 1139. 1139. So 0.1139. Is that clear? So 1.1139. Can you tell me log value of 9? Number is 1 digit. So characteristic is 1 less than total number of digits. So 0. Now tell me whether first row is headed by 9 or not. No, the first row means horizontal line. It is headed by 10. So how to find the log value? I already explained 9 means 9.000. It's a 4-figure log table. So first 2 digits 90, they give the row number. 90th row, 90th row, 0th column, 9542. To it add the number which is in the same row and column 0 in mean difference section. There is no column as such. So 90th row, 0th column, 9542. 9542. So what is the log value? 0.9542. Okay. Now the last one, then we'll stop. Suppose the number is 4121993. Let me explain first, then you will write. There are 6 digits in the integral part. So characteristic is 1 less than total number of digits. So characteristic is 5. Listen to me carefully. We are using 4-figure log table. So we consider first 4 digits. Listen, we use rounding off rule. What is that? If fifth digit is 5 or greater than 5, we add 1 to previous. So we will not find mantissa for 4121. Instead, we will find mantissa for 4122. Now, if you say, sir, if we forgot to use this rounding off rule, makes no difference. Your answer will hardly answer will change by say point not, which is uh, very small as compared to the final answer. Okay, but if possible, go for this rule. Had it been 412133, I would have considered 4121. Okay, so tell me the number which is in row 41 and column 2. Row 41 and column 2. Row 41 and column 2, 6149. To it, add number which is in the same row and column 2 in mean difference section. So it is 2. So I hope it is 6151. Okay, 6151. So what is the final answer? It is 5.6151. See, practice is required. I think enough is enough, because a student who has taken maths here, they are attending from 6 p.m. Homework, you have to find log values. We are considering numbers greater than 1, right? So 1.014, second 101.4, see the similarity if there is any, then 1942, then 79195. Fifth one is 81, say 81.04. Sixth one 63, or I'll make it 631.9. Seventh 9876.7. 8 31.134. Ninth one 18.81. 10th one 876543210. So that's it for today.